All right, so next we're going to talk about while loops. And I'm not going to promise to do the while loop speech in less than 5 minutes because I'm going to throw a couple of things in there as well, some flow control statements. And I am going to throw in something that you can do with a while loop in Python that you cannot do in any other language that will just blow your mind. Might not blow your mind, but it's kind of cool. But first, let's go over what the while loop does, just in case we don't remember. A while loop is a loop that does something while a condition is true. So I am saying while x is greater than 0, print x is equal to, and then print whatever x is. Now, this is a problem. It's an infinite loop. We need to fix that because we need to change the value of x. And I noticed that some people missed this question actually a lot of people missed this question on the little review thing that I did. So I wanted to throw this out there. In a lot of languages, you will see this to increment a value. We don't do that in Python. You'll see this to decrement a value. We don't do that in Python. Instead, what we do is or plus equals 1 or minus equals 1. And basically, these are the same, or this is the same as saying x equals x minus 1. The nice thing about the minus equals as opposed to just doing the plus plus is we can change it. We can say x minus equals 2 or 4 or 8 or 16 or 27 point, not 27 point something, but 27 or whatever. So we can, it doesn't just have to be 1. With the plus plus, it's always incrementing by 1. With minus minus, it's always decrementing by 1. But in this case, we're going to decrement by 1. So 10 is going to go from 10 to 0. And as it does, it's going to print this out. So we get the numbers from 10 to 1, or x is equal to, and then you'll see we get 10, 9, 8, 7, 6, 5. And when it's done, it breaks out of the loop, and we know these two lines of code are what make up the loop because they're the indented lines of code. So it's going to jump to the next line of code once x is no longer greater than 0. Simple, right? Yep, we all know that. All right, that's all. No, not really. There's more. I'm going to move this around a little bit. Now let's talk about flow control. We talked about the pass statement. If I'm writing a really big program and I want to write my code for this loop later, but I know I need the loop there, I got to put code in here. It won't let me not put code in here. And this is one thing about the indentation. You know, in JavaScript, you could just have a couple of empty curly brackets, and I bet you could in Java too. But in Python, you can't just leave this empty. You have to have at least one line of code, and that's what the pass statement is. The pass statement is a null statement. It doesn't do anything. So if I put pass in there, right now it would be an endless loop, but if I left the x minus equals 1 and I put pass in there, it would count down, it wouldn't do anything, and it would end. So pass is just a placeholder. Okay, but there's two other flow control statements that actually do something. The first one is continue. And I'm going to say if, this is a nested conditional inside my loop, I'm going to say if x equals 4, continue. Now I'm going to run this. And as I run it, you're going to see it goes 987653210. What happened? Well, what happened was continue says to Python in a loop, stop your current time through the loop and go back to the beginning. So what happened was x started at 10, it became 9, 8, 7, 6, 5, 4, 3, did all that, or no, it's not 4. When I got to 4 and it said continue, it continued by going back up to the beginning of the while loop. It did not execute this line of code. It skipped that just that one time through. So continue is used in a loop, and it says stop executing this iteration through the loop, but go back to the beginning of the loop and see if we need to do it again. All right, if this had been x equals 1 continue, then we wouldn't have noticed much difference because it would have got up here, or I mean, I'm sorry, if it was said 0, would have got up here and it would have jumped to the next line of code anyway, and we wouldn't have even noticed it was there. Break is different. Break says stop executing the loop altogether. So when I run my break code here, you will see that when it gets to the 4, it stops running my loop and it breaks out of the loop, it breaks out of the while, and goes on to whatever the next line of code after my loop is. Very straightforward. Continue, skips that one time through, and it doesn't just have to be skipping one iteration of a loop or something like that. It can be, you know, you can do all sorts of fun things with your break and continue. I will warn you, there is a command that invariably some of my programming students discover: exit. And they try to use exit as flow control. Do not use exit as flow control. Okay, exit can be executed in 2 different places in Python. There is a standard exit that is built into the core of Python. So if you call exit, your program will end. It is what we call a graceless exit. It does not end well. It just stops what it's doing. It quits. There is another exit. Well, it quits and it actually returns, I think, some diagnostic information. And I have never gotten that deep into it. But you should only ever use that exit as a debugging tool if you're a really good programmer and you need that diagnostic information. All right, there's a second exit that is in the, I think, OS or sys modules. I can't remember which. That one does a graceful exit. You can use that one, but most programmers never need to use that. It's not the end of the world to use it, but I have always, I learned programming in other languages where we avoided the exit, and so I've always found other ways out without the exit. It's not as frowned upon in Python as it is in some languages, but I try not to do it anyway. But if you are going to do it, you got to use the correct exit. Okay, so now you were waiting to find the mind-bending, mind-blowing. It's okay, maybe it's not mind-blowing, but I think it's cool. Now you're all disappointed, aren't you? So, what if I did this? I made this look kind of like a conditional. Okay, so now I have a conditional, and when I run this, you'll notice that it runs the else loop and then it goes to the next line of code. And if you're paying any attention at all, you're saying to me, so what? If I had just put code in the else, outside of the loop, it would have printed anyway, right? Why do I need the else? Because the else, if I don't have the else, it just goes on to the next line of code, right? And you're kind of right, but here's the deal. Here's the exciting thing about this. If I have this, watch what happens. And I bet you, if you're paying attention, you already know what happens. So, the else statement on a while loop will execute when the while loop stops executing unless the while loop stopped executing because it hit a break statement. So this actually can be used in a very useful way. So yeah, can't do that in any other language that I know of. Guarantee you can't do it in Java. I looked it up. I don't know why I like taunting Java people. I apologize. I'm not mean, but I just like Python so much. That sounded awful. All right. Anyway, so that's while loops. While loops. Let me show you the one other big use of a while loop, and this is what I do a lot. And it's kind of like flow control. So let's say I have a function that is a game. And I've written this whole big game, and I stick all of my code for the game inside of a function. And we haven't gotten to functions yet, but this is how you create a function in Python. Congratulations, you just learned it. We will talk about it later, don't worry. And we have fun while we play our game, so it prints having fun and all that kind of stuff. And we don't need all of this other stuff here. This is how, a lot of times when you write a procedural game or something like that, the game runs and then the game's over and then the game ends and then they have to run the game again. So you want a way to run the game and then ask them, hey, do you want to play again? And if they say yes, play again. And if they say no, then exit. So here's what you can do. Here's what I do anyway. I create a variable like x. I usually give it a better name than that. It says while y. And then I will say that while x equals, let me try again, x equals y, the string y. And then I will say while x is equal to y. So basically I'm immediately running the loop. I've already set the condition, so I know it's going to be true because I already set it to be true. And then I call the game. And then I say x equals input to, oops. Do you want to play again? All right, so here we go. And usually I like to give my people, my users, a prompt. And honestly, if I was writing a real program, I'm going to do a little more to it that makes sure that I get a Y or an N and that automatically converts an uppercase to a lowercase or vice versa, so that there's really no confusion, so that the user doesn't have to think too much about it. But for our purposes, this works. So now what's going to happen is if I run this game, it says we're having fun. Do you want to play again? Yes, I want to do. And we're having more fun. We're having more fun. As long as I say yes, but then as soon as I say no, don't want to play again, it's done. All right, so this is a very simple way to use the while loop to control your game running again. All right, so that's it for the while loop. Next up, the for loop, which is totally different than the for loop that you're used to, or at least it's used in a different way than typically it is in most other languages. All right, so that's it for this one. Hitting the wrong buttons. Oh,